B now, where we had, let me see if I can show it to you, where we have this system. We rewrote it in a clearer way. We applied the Laplace with the initial conditions given. We simplified and by elimination to solve for x and y's independently, apply the Laplace inverse. We got these two answers. Now the question is, are these two answers right? And to answer this question, let's go over to MATLAB and let's see if they indeed are. So let's clear all old variables with the clear all command. Then what we're going to do is we're going to define new variables with the sims command, and they're going to be the t variable, they're going to be the s variable, big X and big Y. Then we're going to define the system of x and y, the ones that we solved for by hand. And what are we going to get if we do that? Well, we're going to have s times the big X minus 0, which was our initial condition, so I'm not going to write that, plus 3 times big X plus s times big Y minus 0. All of that is going to be 1 over s. And we're going to have an equality, so double equal sign. The second one was s times big X minus 0, which I'm not going to write, minus big X plus s times big Y minus 0 minus big Y again equals to 1 over s minus 1. And it's an equality, so it has a double equal sign. We want to solve this for the variable x and y. Close this, and we want to redefine the variable x and y with these solutions. So we press Control Enter, and we see if what we get is what we had originally. And here we get something slightly different. Well, let's keep going and let's see if this is just a different algebraic form. So then we apply the partial fractions to the following. So we're going to say part frac of x and redefine x that way. And we'll do the same for y. So for the big Y, we do this. And we press Control Enter. And we want to see what we get. And we get stuff that is the same as the one we had. So let's see, for the x, we had 1/3 1 over s, which is right here, 1/3 1 over s minus 1/3 s minus 1 squared minus 1/3 s minus 1. So we got the same thing. And for the y, we got 1/3 s minus 1 plus 4/3 s minus 1 squared minus 1/3 over minus 1/3 times s, which is the same thing that we have. So now we apply the inverse Laplace, I Laplace of x and I Laplace of y. Inverse, this is y, and this is going to be my small x of t. This is going to be my small y of t. We press Control Enter, and what we get out of this, and I spell this wrong maybe, unrecognized function or variable t. So let's put the t in here. And now we get this, which is for x 1/3 minus t e to the t over 3, which is what we got, minus 1/3 e to the t. Okay, and for y we get 1/3 e to the t plus 4/3 t e to the t minus 1/3. And now what we want to do is check the solution by plugging it back in. So we had our original system, which was the derivative of x with respect to t plus 3 times x plus the derivative plus the derivative of y with respect to t is equal to 1. And we want this actually to output, so I won't put a semicolon. And now the derivative of x with respect to t minus x plus the derivative of y with respect to t here minus y. All of this has to be equal to e to the t. And we got to get an equality if this is indeed the right solution. So we got 1 is equal to 1, which is true, and e to the t is equal to e to the t, which is true. So these are solutions, and the solution is verified. I'll see you next time.